Hello and welcome back to Compiler Programming. Today I want to work a bit more on the metaprogramming capabilities, and in particular I want to be able to uh, reflect and reify values. So what that means in practice is that let's say that I have something like, I don't know, 40 here, right? I want to be able to, and internally in the compiler, each value like this is represented by a value struct, something like this, right? It has a descriptor, it knows where it's stored, there is some stuff for overloading and other things, but basically these two are sort of the most important. And if I want to have a powerful metaprogramming, I should be able to write functions that are able to construct these things programmatically, right? I should be able to construct a value just by specifying a descriptor to it and specifying the storage. I also should be able to manipulate a value on this level instead of manipulating it on the level of a number. And those are sort of two mirrored concepts. One is reflection, which is sort of getting meta information about the value, or like lifting a level up, and the verification is going down one level. And technically you can go any amount of levels, like you could have reflection of reflection of reflection. Nothing technically stopping you from that, but there is sort of limited usefulness coming from that. So anyway, the idea is I want to be able to have sort of compile time functions that receive one of these instead of an actual value and get back one of these, and then you can sort of sprinkle them into the program. Okay, so how would something like that work? Well, first let's get a test. And this test would be about just trying to get the reflected value. So first of all, this will be a value star. So we have something that returns us a pointer to a value. It doesn't get anything. Now we have to copy that again because C. And we are ready. So here we say reflect, and I want it to be an operator. So actually, this should just stay checker, to be honest. Okay, something like this, and it doesn't get anything. And here it would return us a pointer to a value. And this is for now the syntax for the pointers. I still haven't decided if that's a good way to do this. Okay, and the idea is that I should be able to do something along these lines. So I want to use this operator for uh, the reflection. I think it is kind of an interesting, so semantically makes sense, right? It's kind of looks like, I don't know, a mirror or something. I'm also thinking of how would verification look like. There are a couple of options. I can do sort of something like this, where I put this on the right-hand side and then it is put back. I might also do a different operator, something like this. I don't know. Let's start with reflection and then we will go from there. Okay, so I get the checker, and then I need to be able to verify that we correctly constructed the value. So the value star actual is something like so, and then I can check that actual descriptor. So this has a special type, which is descriptor number literal. And I can also verify that we have storage tag, which is storage tag static. right? We know statically what the value of this is, so this is why it is in a static storage. This is the basic idea that these slash operator backslash is gonna give us the reflection. Now I should be able to use backslash operator for reflection. Okay. Now we can try to run the tests. First of all, it fails. Why? Value star, illegal, use of type. Right. This needs to be in extra set of braces. Okay. And I cannot write test. Let's try to run the tests and we should see one failing. Let's see why it fails. Well, it's not a very descriptive error message, but essentially what that means, actually let me try to get a better error message so I can do something like check tests context result. So I think we can also do the following and context. And now we should be able to see the error in a more detail. Okay. What is happening? Well, apparently we still count, which is kind of interesting. I need to look into that, why there is no more detailed error. But anyhow, the point is this fails, and I happen to know where it fails. So if we go to, well, essentially we don't have an operator, right? That is doing this stuff. So here's where we define operators. And there is a good question about precedence of this. I think it needs to have sort of the highest precedence. Do you think about how it interacts with the function call? But regardless, for now, let's just make it the highest precedence. So I'll just have 30 and say that it is slash slash because we need to escape it inside a string. It's not just that it's a double slash. It's a one operator. It is a right associative. It is a prefix operator. And we need to handle reflects operator. Okay. Handle its operator. So let's put it somewhere here. Static value star. So the hope is that once I implement this reflection, I would actually be able to implement a lot of other operators in terms of this one, right? Because if you look at what this thing does, it actually manipulates these values as in these kind of structures. So if I can have a compile time function that manipulates these kind of structures, I should be able to move some of the stuff that is currently inside of compiler onto the actual sort of user land. And I need to be careful about exactly what I move because you need enough base functionality to be able to construct the rest of the functionality, if that makes sense. But some of it should be doable. Okay, so we have reflect operator, and making one should be relatively straightforward. The only real issue comes from the fact that basically I use values by pointer everywhere in the compiler, and right now it's a bit shaky about in the boundary between compile time execution and runtime, because it is unclear where this thing points to. Like, is it part of the something that is only available inside the compiler, or is it part of something that is also gonna be available at runtime? Anyway, I think we're gonna be fine, but it might be a bit tricky. Okay, so how do I do this? Basically, I need to return a value that is uh, pointing to a value. So how would that look like? We need to say, well, first of all, let's do like this. We verify that we have, that actually needs to be other way around here as well. Value, source value, I guess. I don't know how to call it best. Okay, and now we need to start doing things. So we need to return a new value. The type of that value will be descriptor value pointer, and storage static is going to be source value. Static inline. I guess something like that. And I also need to do provide the range for this source range. So let's spread this out a bit, maybe, so it's more readable, and something like that. I'm not sure if that exactly is that easy, but it might be, at least for the first pass. Well, I mean, let's see what that does. We probably will have to get out our debugger soon, but at least that is the start. Well, so I guess this is not working. And the first thing I actually want to check is, it's very possible that I'm not even tokenize, tokenizer. Somewhere here there is this list, right? Yeah. So this is what I thought. I have the forward slash as an operator, but backslash is not, and I just need to make it one, because backslash in the function, in the strings is handled separately anyway, but here it is like this. And I think that's why I didn't get to here, because like I didn't get the error correctly, because it was tokenization error and I don't handle them well just yet in tests. So let's see if that helps. Okay, that is still no dice. Okay, as I said, time to get into our debugger and see what is going on. First thing, of course, is to check if we are even getting to where I think we should be getting, and then we can go from there. Let's handle a reflect operator. So are we getting to here? Tell me, Visual Studio. No, we're not. Okay, so then it narrows down the problem. We need to go to something like parse expression, I guess. And then we can see if that is the issue. So let's stop, I guess, here and see. Okay, we are not even getting to here. Huh. So it feels to me that the problem is indeed in the tokenization part of this. So let's start here and step into this function and see what is going on. So that's not the interesting part. We go from here. We load this. It's fine. We do import module. Blah blah blah. Okay. Parse. So what is the source file here? Can I look at the file? File, path, text. So we're still, this is still prelude. Okay. So step out a bunch of times. Okay, that's fine. And now we can try that again. And now the file is should be the right one. Okay. All right. This is my problem. That I also forgot to do double backslash here. It's also string. Maybe I should start changing tests so that they all load text from files. I don't know. It's a bit unclear what is the right thing, and it's also very unclear to me why the hell Visual Studio hoards the access to the files. Like, why does it keep that file open is beyond me. So I have to close it if I have any hopes of actually saving this file, which is just completely ridiculous, but whatever. Let's try again. We still have an issue. And just to verify that it was saved correctly. Okay. Well, let's bring back Visual Studio and continue debugging. Okay, let's go back to parse expression. Maybe now we will be more lucky and we will actually get into here. Okay, now we actually do get into parse expression, which is good. What is the expression that we are parsing? And that does not look like what I want. Okay, I guess that's fine. Values, right, we are parsing some inline text and the source ranges are a bit screwed up when that happens, I guess, which is not great. Source range function, yeah, so here source ranges are fine, it's just that in the Full one, it is not great. Okay, so I want to do this again. And now we are parsing the... Oh, okay, right. So we don't actually have value defined globally. So what we need to do is we need to say mass is import uh, mass, and then I need to say mass dot value. Right. So we should be able to now access this thing. Okay. Is that any better? Okay, of course. This is so annoying, and it got like that only recently with Visual Studio, that you can't freaking save the file when the Visual Studio has it open. So whatever. I guess I'll have to edit my tests in Visual Studio. Okay, let's check again. So yeah, this is mass value. We can go through this check now. All right, this is the group. It should be okay, fine. Okay, more imports. This is not an import thing. More imports. More imports. Add file path mass. Okay. So I don't think we ever got to here, right? If I run the tests, I think we still don't get the right thing. Yeah, which is very, very strange. Okay, let me be more careful maybe with how I'm doing that. Let's go in here. It's fine. Right. Run to cursor. Okay, so what is happening right about now? Context result is error. And it says it is unknown field. Right. Another thing I forgot to do is in here, I actually need to expose this outside of the module, right? Because this is the module that I'm importing in here. When I do this import mass, what it actually does is this is how that module is defined, and I need to define more things in here. I need to provide the value, and that should be type value, something like that, and compiler scope and source range. Okay, let's try that again and see where we get now. Now step over here, go here. Okay, well, that is progress. And I even roughly know what is going on. Right, and this is what I was saying about the pointers and how they can be tricky. So the way I have hacked it together right now is if we realize that we have a pointer coming from compile time evaluation, then that pointer is sort of needs to be put into this special mapping that tells me how to how to say this, how to map between the memory that is in the compiler and memory that will be in the program. So like the globals that are available for the program. And I'm not particularly proud of that solution, and I'm still trying to figure out what would be the better way to handle this. But I guess for now, that is how it should be, right? Because essentially, what I'm asking the system to do is to provide that value at runtime, and I need to have it there. So mass handle reflect, right? And in here, I need to do something that is also happening in here, so I can steal how it's done. Right. I don't actually remember if that is how it's supposed to be done. Um, hmm. Allocator, we allocate the buffer, we have a descriptor, storage, right. I think something like that. So we actually can be in a lot of pain here because the structs are copied field by field, and I think like I recurse even to pointers, and like because we have pointers as like here we have technically other pointers, that might be problematic. And this one as well. Ugh. Let's see how far I can go with this. So this points to the source value, and this uh, this is tricky and makes my brain hurt every time I try to think about this pointer situation between runtime and compile time. But let's get on with it and try it this way. So I create a new mapping, and that mapping is saying that this value yeah, I think that's how it's supposed to go, but I'm not entirely certain about that. Right, and I also apparently screwed up somewhere. Compilation, yes, that is context compilation. Try again. Well, apparently, I still have an issue, but I believe that's a different issue from what I was having before. So what is the issue here? Well, the issue is that tag is not memory, or rather, uh, location tag is indirect. And what is the actual target storage? Target storage is memory. Memory tag is instruction pointer relative. So that's a label, right? Yeah, that's a label. And it's a label in a data segment. Okay. Um, Let us look at what a sign does. I guess, okay. So what is happening here? If this might be slightly dangerous, but I believe this case needs to be earlier than it is. That this actually needs to be the first thing that happens. Maybe. Although it looks like it was... Wait. Right, it was inside static. Mm, okay, let me rerun the test. I want to see the sequence that actually got us to this point. So we are assigning. What are we assigning? Source is static and its descriptor is what exactly? Its descriptor is value. So this is okay, expected result, value force. Right, so this is us trying to return this escaped value to the outside world. Okay, what are we assigning in here? Right, this is us assign um, this is us dealing with the pointer. And as I said, when we see a pointer that we're trying to return, and that pointer is was generated inside of the compiler, we do this special sauce, and we also need to, as it says here, go in and handle all the um, nested cases of it. Now, the question is whether the target, whether this check needs to be here. I can try to disable it for now and see what goes on afterwards. It's bigger somehow. Okay. So I want to look at here now. So source, it's not the one, that's not the one, that is the one that I'm interested in. Okay. So now we will get into the next problem. Exactly. Which is that it tries to copy the descriptor, I think, and runs into the same problem. Is that the case? So what is happening here? Storage field access. Okay. Right. Source field. Okay, but the source storage is static. Okay. So why am I ending up in this case? Struct storage. Well, wait, what? Struct storage is memory. Right. It is the target storage that is uh, problematic. Okay. So this is tricky. This is very tricky. Here's the issue that this brings in. I have this special case that handles when we are trying to assign a static value uh, to uh, to global memory, which is something that happens during compile time. But when I for that I actually need to have that static memory somehow referenced, but I do not. So I don't have a concept of saying take this label and have an offset from that label to be able to put the value in. Okay. How can I fix this so that it is not completely horrible. Um, right. I mean, sort of technically, the issue here is that I'm trying to bring the value into the runtime, and I don't actually need this. I can mm, do it somehow differently. So one thing I could do is I could change the test in such a way that it it does what I want. So let's change the test. I know it's a bit of cheating, but I don't want to like go 10 layers deep into trying to figure out how to deal with the pointer situation. So what we're gonna do instead is we're gonna return a bool, and that bool is gonna tell us whether the uh, so I escaped this expression, right? And now I should be able to say that this descriptor here is mm, descriptor tag is mass descriptor uh, tag and struct. I should be able to swing something like that. And that is enough of the test that this kind of thing works. Probably. For that to work though, I do need to also include more of the stuff here. So we have this scope define enum that now needs to say descriptor tag and descriptor tag and then descriptor tag a few more times. Um, I probably do need to improve the setup here so it's not so verbose to do this. Anyhow, let's check. Well, we are still failing. That is not very encouraging. And another thing I need to do is actually change the type here because it doesn't return bool anymore. And I just need to do this, I guess. Okay, if it's 0, let's try again and see where it fails. I probably should make the check here. Okay. So far it is actually successful. It means it parsed fine. Okay. Do we get the value? Yes, we get the value. So the issue happens when we try to compile function body. Well, let's go into here and see what's going on. That's not interesting. That's not interesting. It's fine. Fine. Define values. More definitions. So probably this is where it fails. Now the question is, why does it fail? Context. Result error. Type mismatch. Interesting. Mismatch exactly of what? So expected S64, but got opaque. Right. That is another problem that I have. Damn it. R. That's more things to go on my list to fix, but essentially we need to simplify the test even more for now. The issue here is that I am trying to compare, but right now compare does not work on arbitrary types, and I'm not even sure it will ever work on arbitrary types because it is sort of it's unclear what it's supposed to do in this case. I might say that it's okay to compare any APAC types, but even that is a bit shaky because you don't know that it's okay to compare APAC types. I might mark enums in a specific way, but I think the better would be to really just be very explicit and say, yes, if you want your thing to be comparable, it needs to be defined as comparable. But I can do this. And then we are gonna be in a better shape. So descriptor tag, and descriptor tag struct. Okay. How are we doing right now? We still have a type mismatch. Yay! And it is the same one? That is a bit... Wait. It expected a descriptor type but got a descriptor scope? Wait, what? And where did it happen? Right. That is another thing I need to look into. The list keeps growing, but I do want to get this freaking test to work in some sense, so we will make that work. Okay, so what is happening now is that the way I defined sort of the way I made enums work is a bit hacky. if we look at scope define enum, what it does, it defines the it sort of defines enum as a scope with a bunch of number literal constants in it, and that is a bit hacky, and I still haven't figured out what would be the better way to define enum. But from C perspective, those are enums, so it is okay. But what is missing is I cannot really refer to the type of the enum. So here I need to say something like this, uh, which is a bit awkward because of the potential naming conflict. So I'm not exactly super happy about this, but this is what I need to do. And in here, I then need to do not the const descriptor, but value star enum type value. And then enum type value descriptor, that's good. And type would be enum type value. Is that correct? Now I need to say like type operator fixity value, and I just hope I actually generate those, but if not, I can generate them. That's not really an issue. Type and type descriptor tag value. Okay, I do generate those, at least in theory. That is okay then. And now I need to change the test to here say underscore type. It is very, very dirty, but it is what it is. Well, that's not encouraging. Now we're just infinite looping. And why does our type, what? Wait, what? What's happening? So first, let me check that it is actually this exact change that is screwing us over. It is. That's kind of weird though. Right. I'm defining it in the wrong scope. This should be defined in the inner scope. That's why there was this infinite thing. Well, I think we are finally done with that part. So somewhere in here, there's this test. Yeah, probably want to make skip tests like less bright or something, or even not print them. I don't know. Anyhow, now it finally works. So right, as we saw, there is a bunch of things I need to fix. With this stuff, there is a big thing with the pointers that is very unclear how it's supposed to exactly work. But the idea is there, right? We are able to construct a value, and we are able to access now the descriptor of something at compile time, or even technically this is at runtime. Good. So let's do git log rg we are on episode 162. That's okay. So git add. Actually, before we do that, I need to uncomment the feed and check that all the other tests are still passing and I haven't screwed something up terribly there. And I did screw this up. Apparently, with unreleased register. What? What is that all about? Okay. That is very, very strange. Let's look quickly at generated types. Type operator fixity. Wait. All right. It is defined in here. So type underscore, right. Yes. Must define type value. Okay, descriptor, mask type value, descriptor. I mean, it should be fine. So what if I undo this change? Does that actually fix the test? Because I don't think I changed that much. Yeah, it does, which I find extremely strange. What if I just comment this out? Still not really working. Right, right. Because I'm doing the wrong thing. I need to do the following: cast descriptor star, and this enum descriptor is storage static sc type storage cast descriptor star, right? That is what's supposed to happen. Not even that. It should be descriptor, like so. The whole thing with the way I define these kind of global values, that in the C compiler is a bit finicky. But I'm not sure I can do much better with C because it doesn't really have good support for typing complicated stuff. Anyhow, this seems to work now. Episode 162, and say and a basic reflection setup. And I do want to try to also get reification in. I have no idea if that is going to actually work. It also will test whether this parsing of values works correctly. Not values, sorry. Parsing of operators. I will try to make it so that, like, if you put it on the left and on the right hand side, it will do different things. So that's why it is. We also have a left associative version, and this needs to be suffix. There is one prefix and one suffix. I think that works. Let's see if that is the case. And we want to have a version of this that is saying that Reify and okay, and then we selected value. We need to check if a reflected value descriptor is not descriptor value, then we cannot reflect, right? We should complain to the user and saying that cannot verify non-value. This is where the whole thing about reflection starts to be problematic, is to explain stuff, right? Cannot verify a non-value value. What does that even mean? Something not verify something that is not of type value, something like that. Selected value source range, and it's not a parse. Actually, you're right. This should be a type mismatch. Yes, we want this error here, not the parsing one, because that will give us automatically what we want. We say that we wanted expected descriptor value. Right. So this is better. Okay, and return 0, I guess. Okay. If it's not a value, then we can't really help you. If it is a value, though, then it is pretty straightforward. We just need to say storage static as C type, and that would be reflected value storage, and we are gonna do something along these lines. Because here, as you see, we are storing the pointer, and in here we are extracting the pointer out and returning that to the user. Yes, result descriptor is not a thing because it is a reflected value descriptor, and it needs to be like that. Operator suffix It's called postfix, right? Okay. Well, let's add another test. Use so here now we say that it's a prefix, and here is postfix, and uh, for that I don't think we even need to do this. We can just do a 64, 64, 64, and it's 42. And now at first I want to check that it works with the braces. I don't want to go into the operator precedence stuff, but I will then try to run it without the operator precedence being explicit with braces. So let's just run this test and let's see how we are doing. And of course we have a problem. Test context, result, type mismatch. Ooh. Right. Because I did the wrong thing. In here, it's supposed to be value pointer, not value. Let's try this again. It is still 0. Okay, what is it this time? Test context, result, error, still type mismatch. Did I put the wrong thing? Oh, I mean, I did forget to put it here, but that should not be the problem. From what I can tell. Maybe I'm wrong. Okay, back to this thing. Right. So this is where I forgot to do something, and that is when I'm Reifying, I actually need to parse the value on the left, or more like I need to compile time eval that value on the left. So, right. Compile time eval. It should actually be something like that. Probably. I'm not 100% sure, but we can see that is what we want. I mean, on the good side, the whole prefix postfix thing seems to work, so I can indeed use the same operator for both sides. But what is the reflected value now? Well, now it is the right thing. And we are getting out. So what is our result value? Well, it is a number literal, so that is very promising. So I think we are actually in a good place. Run to cursor, and yes, now our function actually compiled, which is a very good sign for us. And we can try to check. It looks like everything is fine, and we are exited with status code 0, which means all the tests have passed, or more precisely, this particular test has passed. Now we can uncomment test, make sure we run all the tests. Right. So the first part with reflection is a bit bumpy. I need to figure out, as I said, how all of this actually supposed to work. I mean, one way I could sort of work around this whole pointer problem is to just not use pointers, which is, I mean, not always possible. I can replace some pointers with identifiers that will help a bit, but not 100%. And in general, it would be nice if the user would be able to use pointers, but I still, as I don't have a 100% solution of how that is supposed to work. I should probably look at other languages that try to do something like that. Um, because the thing is, I think a lot of my problems come from the point that I'm trying to make sure that we don't output unnecessary stuff in the binary. Like an easy solution to this whole pointer problem would be to allocate everything from the from the global memory of the resulting executable. That is possible, but that is problematic because, first of all, it is limited to 2 gigabytes because of the executable format, or I will have to do I will have to be way more careful with memory and making sure that I never like allocate things I don't need and then clean up. Like it goes into very weird territory, or I have to figure out how to solve the problem that I actually have, which is something I need to think about. Anyhow, this is roughly what I wanted to do today. I couldn't get to everything, but that is fine. The big point is this stuff works. I can actually try to run it like this, which looks kind of fun, and see that that is working. The only reason it wouldn't is if I have something with a greater precedence, but I don't. So this funky stuff is turning the 42 into a reflected value and then immediately refies it back into being a number literal, which is fun. And let's see what else I can do with this setup now in place. Okay, that would be all for today. Thank you for sticking this far with my struggles, and hopefully next time will be better, and I'll see you then.